Coalesce podcast. My name's Grant.
Not Meg.
And we have Andrew back with us, and we wanted to just get into, we kind of had a discussion before about some history and things like that, but we really wanted to get into a few more of the technical details about how that application actually is structured, how it runs, and some of the kind of core features in there. Because a lot of times when you write like SPA applications, you'll have an API backend, and then you'll have a kind of a standalone web front end. And while you can write them this way, that's not how the Coalesce the Coalesce template project comes structured out of the box. And so we wanted just to chat about that just a little bit, and just ask Andrew a few questions and talk through that. So Andrew, coming just the base Coalesce project, you're going to have your data project, which contains all of your stuff for just your data, your EF stuff essentially. And then you have your web project, which has all your web things in it. Talk a little bit about that particular structure, anything special that would help people to kind of understand just that part, and then we'll kind of dive into the web piece as well.
Sure. So I actually up here right now, loading VS Code. I have the actual the core Coalesce repo. So not actually a specific project, but it has a Coalesce project inside of it. So yeah, as you said, there's a data project. In this case, this one is called coalesce.domain. And then you'll have a web project, in this case called coalesce.web.view3. So as kind of not even I'd say as a general rule, but actually as an absolute rule, for Coalesce's code generation, the data project is the inputs to the code generation, and the web project is the output of the code generation. And that principle will never be violated, because it's in fact becomes very, very difficult if you want to violate it, to have the web project, which is the output of the GoGen, to also be inputs to the GoGen.
Yeah, right.
If you generate, you end up with code that doesn't compile anymore, then I can't really have this input
right
to the code generation, because they won't have any idea what's going on with that code. You'll see that listed in your Coalesce JSON file in your project. Really, this file just acts to serve as the configuration for the GoGen. It just tells it where the projects are that it needs to look at.
Right, and there are some other features you can put in here, some flags and things. I think those are in the documentation, right, Andrew?
Yeah.
I want to go into those in.
If you're in the documentation, we have this section of the topics here, config GoGen. This describes all of the features you could put in the Coalesce JSON file. Again, it's just describing how to load your projects, really. Where is the CS proj for each file, what framework? You usually don't, you really never have to specify that. But some extra options that MS Bill, you absolutely have to do a very unconventional setup.
Yep.
There's configuration for each generator. You will note in the default project template that the scripts generator is configured to use the kind of standard convention for Vite. We didn't always use Vite as the front end server, so that has kind of changed. That's why that has special configurations, because we want to kind of mirror the conventional project structure on the front end for a Vite-based Vue project, rather than come up with our own conventions that you can't then correlate or reference on any other standard documentation for those technologies.
Yeah, so one of the things that you typically find in a project like this is you'd find your front end oftentimes separated into kind of an API piece, which was in C#, and then maybe just a pure like TypeScript thing that was, or a Vue app that you would start with like npm run dev or something like that. Now here, Andrew, you've worked some things into the app such that when you start it, the Vite server starts as part of the application starting it. Can you talk a little bit about how that works?
Sure. I just pulled up this documentation page, which I realized doesn't actually have this documentation. If you actually go look at the Coalesce repo, in our current big issue of documentation stuff, that is actually one of the things that we're planning to add some documentation to, is around how that works. So Vite is a really kind of complete suite of front-end development tooling. So it acts as both your build, really as your compiler for your front-end app. as well as your development server for providing modern development features like hot module reloading, so you can edit your code and save it, and it's automatically comes up with your updates in the browser.
And effectively, this is rolling together things like TypeScript and a bunch of these other compilers for SAS or whatnot into a single thing, as well as that hot module reloading, watching files change and all that, sending a signal over to the browser to say reload. That all that stuff's wrapped together in Vite. Is that what that's doing for us?
Yeah, so it kind of glues all the different technologies that you're going to use together. So TypeScript and Vue and SAS, and many other languages that you may be involving in your front end, and then a whole bunch of fun stuff on top of that. So it really provides quite a lot.
I think something important to note too, this is for your development environment, so it's
and for your production build, so it's doing all of that.
Cool.
So the way that works in development is you typically have in your program CS, you'll find this use Vite development server. So this is provided by Coalesce. It is actually technically agnostic to Coalesce, but in lieu of building this out as a standalone package, we're bringing that in and maintaining it as a separate thing. We just bundle it with Coalesce. So what this does is on startup of your project, we'll launch the Vite development server and then proxy requests to through to it from your ASP.NET Core web server. So some of the goals behind this is to make your development experience as close to your production experience as possible. For example, in a typical, in kind of a typical scenario where you may have an API backend and then a front end built with Vite and whatever front end technology doesn't have to be Vue, it could be React, Angular, or any of the other technologies that Vite supports. You would really have two separate processes. You make two terminals, split your terminal in half, have your backend on one half and have your front end on another half, and they're really pretty separate.
Yeah.
This aims to kind of bridge the gap there and bring what's happening closer to what it's going to be in development. Because once all of your front end assets are compiled, those are all going to get compiled into your dev folder, including things like your index HTML sitting there in the root of that folder. And that's how your kind of root page of your SPA application gets served. It gets served as a static asset by your ASP.NET Core server in production. But that's not actually what would be happening in development if it weren't for this. So this is actually doing some extra steps on top of this to copy assets from the original source of your index HTML, which is in your SIC. Sorry. Where is it again?
Yeah, just search for that.
In the root of the project there.
The root of the project. Yeah, that's what. Okay, there we go.
So this is the actual source location of this file, which is not actually where it gets served from in an ASP.NET Core application. So it's really just bridging the gap between kind of the standard practices of modern front-end stack using Vite and the development practices of an ASP.NET Core application. So ultimately, all it means is you can do a .NET run on your project, and now you have your whole app up and running. It starts your front-end server automatically behind the scenes. Keeps it running. If it crashes, then it'll restart it. Does some extra stuff to make a lot of your static assets actually bypass the ASP.NET Core server and go directly to the Vite server. It does some rewrites and stuff in the index HTML because it turns out that makes things a lot faster. When in debug, if you're trying to send those all those static assets through your ASP.NET Core server, when it's running in debug, it turns out that's pretty slow.
Yeah. Yeah, and the experience is super nice. Andrew, can you talk a little bit about what happens? So that's in development mode. You're really running that Vite server that then is serving up all your stuff as you change files. And as Megan and I have kind of shown during our different sessions, we're really changing those files while we're running. And Vite that's running as a result of getting started by ASP.NET is recompiling those things and pushing them forward to the UI. And it's just this really super nice, easy development environment, even though you're actually running the app inside of Visual Studio in debug mode, but you're actually editing the files in VS Code. At least that's how we've been doing it, which has worked really well. When it comes to doing the actual production deployments and you do the compiles, and you can look at how some of those work just by looking at the code here in the repo. But what kind of stuff happens when that build gets done, and what do you kind of end up with when it comes time to actually deploy the app?
Yeah, so to build the front end piece, you're just going to run, by default, you're just going to run npm run build. That's going to run the build script in your package JSON. This is actually not package JSON for front end app, but get there. So that will just run Vite build, which just by default is a command to build for production. So it does all the production optimizations and minification and all that kind of stuff.
And those are just controlled with standard Vite things, right?
Yep.
There's all the documentation. Just go out, look at Vite. You can see exactly how it works.
Yep. So you have your Vite config file. Ignore all the TypeScript errors in here because this is a very unconventional project. But we're just doing things in here, adding the view plugin so that Vite knows how to compile view. There's a Beautify plugin, which you may or may not use, that does some kind of optimization stuff and auto imports and things for using Beautify. You'll see the ASP.NET Core plugin in here. And sorry about all the errors in here. This is not a normal project. That doesn't do anything when you're building for production. It only does things in development. So all those assets just get compiled up into whatever shape Vite deems appropriate for your project, and dumps those into the www group folder so they can be served as static assets.
Static assets, and effectively, then those are just being served as static files really early, typically in your pipeline, just as if you had images or whatever in there. So effectively, when you're debugging, you have this kind of running together. While the ASP.NET server is serving those in production, it's really, you have a standalone website that is a static site, and those are hitting the API back end. Now, the nice thing is they're coming from the same source, and so you don't have to worry about things like cores and things like that. So there's some advantages to just kind of having that all packaged together as one. You only have a single deployment, those kinds of things.
Yeah. So we can look at a slightly better example of that over here in the actual repo for the Coalesce template, which is actually a separate repo over here. But if you go into the content, the web project, we can see kind of the default set of configuration for Vite. So we have some plugins in here that we think are pretty nice to have. It's kind of based on stuff. So plugins for automatically importing components. This actually is this kind of generic auto import plugin rather than the Beautify specific plugin, because we also have auto imports for the core Coalesce components. So that you don't have to import those by hand or register those by hand. That happens inside of Vite. It's easier usages of a C input or a C select component. Says, okay, let me import that for you. I know where to find that. Just takes the burden off of doing some of that development.
Great, that's awesome. Hey, just kind of wrap up. Meg, did you have any other questions about this? I'm going to go ahead and ask about some Cogen stuff, but did you have anything before we move on?
No, I think that's it for Vite.
So, Andrew, can you just pull the cover back, or the drape back a little bit on what actually happens when we do? Like, how does that Cogen work? Like, what's a little bit? I mean, again, not deep, but just a little bit about, hey, we're generating a bunch of code. A little bit of an idea of how that happens. I know initially when I wrote the first version, the entire thing ran off of reflection. But then we realized there are just some things that, as you and I started talking about this, that we just couldn't do with reflection. Like there's certain things that are really hard to get to because they're not included. Because when you're reflecting on the actual compiled library. And so we went into Roslyn and started using the symbol libraries and things like that to try to get to all this stuff. Just talk a little bit about like what exactly is going on here.
Sure. So at a high level, what we do is we take in the configuration file. We look for that in your current directory, and we'll crawl upwards until we find one, or you can pass it in as a command line argument. Use that. We say, okay, here's where your projects are. Those are specified in the config file. We go and then we run some custom MS build targets against those projects to get out some metadata about those projects. So we go and ask MS build, hey, what are all the dependencies of this project, all the DLLs dependencies of that project? What is the name of the project? Where is it? Actually, we know where it is, but anyway. What is the root namespace of that project, and kind of all these other properties? What is the .NET framework level? What is nullability turned on by default? What is the C# language version used? All of these things that we need to inform both how we gather information out of the project and also how we generate the code. So once we've gotten that metadata from MS Build, we then use that to essentially launch the Roslyn compiler, which is the C# compiler. But that's all happening in memory within the code generation. So we're not spawning it. We're not just running, csc.exe to, go compile some C#. We're actually loading up the semantic model of your application using the Roslyn APIs, and then using that to go and look around and say, okay, what are all your types that you're exposing with Coalesce? So that's basically the first thing we do. We look for anything annotated with Coalesce, which is the attribute that we use to expose things. From there, we'll find your DB context. And then from there, we'll look at all the DB set types on the DB context. Then we'll go look at those classes. We'll look at all the attributes, grab all the properties, all the methods, what types do the methods return, what are the types of the method parameters. So we'll kind of crawl over your entire application until we can't find anything else that we need to be.
So all the classes, if you find like a method that returns another class, you're going to go find that class and all the details. So you end up with a huge list of all the things in the project, just effectively all the classes and types and all that.
Yep. So from there, as we're doing that, we're building up kind of an internal model of all your types.
Right.
Which we mentioned on the previous episode. We kind of have a dual stack version of that, so we can build that entire metadata structure using either the Roslyn metadata, which we do for the code generation because it gets us a little bit more information than we can with pure reflection, or we can build that with reflection, which we do at runtime to drive some of the internals of Coalesce.
Right.
But it makes it really useful, really convenient to work with, having that common data model between the two, kind of between the code-gen side and the runtime side, being able to work with the same data in both places makes it a lot easier than if we didn't have that.
Yeah, because there's certain things, and maybe we just talk about that for a second. There's actually certain things that are handled at runtime as opposed to having a bunch of code. Because there's this balance between, like, for example, all the controllers are generated out, but when it comes time to doing your searching and sorting and things like that, if I remember correctly, some of those things are not code gen. They're actually built as code that uses this model built at runtime with reflection to find all the things and be able to do that. Is that still we're talking about, Andrew?
Yeah. So so for some things, like you just said, the search it's in this one. There's a few layers here because there's different, kind of the base data source classes we kind of build on a few layers of things, because you might you might have a data source based on entity framework, or you can actually have types of entities that are actually exposed by Coalesce that are not based on the entity framework, called standalone entities, which you can read all about in the documentation. But things like the search, it would actually be really hard to build out generated code to perform the search.
Yeah.
It would actually just become crazily complicated. Probably about as complex as it is to build out the generated regex classes. It's that kind of a thing. So we do all the searching and finding the properties and doing all that dynamically at runtime, which has other benefits too. The way in which we search is dependent upon the current user. If you're a user who's not allowed to read a specific property due to the role attributes on that property, then we're not going to let you search that property. And so all that kind of really has to be dynamic.
Yeah. Okay, so going back to kind of the code gen parts, we've now loaded up our models. We've done that. We pulled the to the web and the data project into Roslyn. We have our models built, and now we're going to go ahead and start building out that code. There's generators in there that are doing this stuff. Just pull the cover back just a little bit on that.
Yeah, so we have a pretty robust abstraction around doing the code generation. We have these individual generators, and then we have these meta generators which spawn the other generators, and then we have these root level suites, of which now there is only one now that knockout is gone.
But it could eventually open up for a React or an Angular or a something else in the future at some point in time if there was a good fit for them.
Yeah. So, really the entry point to actually executing the code generation, once we've gathered all the data, which this reflection repository object is really kind of the root of that data. It exists and for both reflection and symbols through Roslyn.
So you can basically build that reflection repository either through reflection or through the Roslyn symbols. Yeah.
Yep. And there's just a few things you can get through one way, but you can't get through another way. Things like method XML comments are not available through reflection. There's other ways to load those if you generate the XML.
Sure. Yeah, right. But this does it automatically.
So we have the root suite. We spawn these generators. This nice fluent API that we have here. So the scripts generator, for example, is the generator for the 4 front-end layers in the view stack, the models, the metadata, the API clients, and the view models. This API generator models is for the DTOs. So the generated DTOs are generated by this one. And then we have the controllers. So specifically the controllers for view, which actually is just the API controllers.
Right, which those would be shared.
The controller generator for knockout looked a bit different.
Yeah.
So if we come into this, we can see, okay, the scripts generator generates out the metadata models, view models, and API clients. If we go into those, we find that really at the end of the day, it's just a glorified string builder.
As most CodeGen is.
These used to be written as actually CSHTML files. CSHTML as a templating engine, which presented some challenges trying to use CSHTML to generate C#. You end up with layers and layers of sequences and characters because you're trying to write a C# keyword, but that needs to not be interpreted by the CSHTML file. It just needs the output.
Yeah, because we started there, and then I think we tried maybe some even T4 templating for a little bit, and then we eventually just said, hey, let's just build strings. It's easier.
It turns out that we actually have more of our code in the code generation is logic about how to do the code generation, more so than it actually output the code generation, which is kind of I suppose the dividing line there between when a templating engine is the right choice versus string builder is the right choice. Is are you avoiding the template syntax more than you're utilizing?
Right.
So really, we just have a bunch of methods on here. This build output async is the root method. We built some kind of header stuff at the top, and then we just iterate through all of our classes. So we look at the enums and everything that has an API, and finally our external types. the types that don't have APIs and finding our services. And we just go through those and call them methods, which ultimately build strings.
And really, at the end of this, we have a whole bunch of files that are generated, and all the files have that .g. Explain a little bit about the .g. There's some magic to that with different tooling, right?
To an extent, it's just an indicator that it's a generated file. I believe C#, with some of the analysis, some of the analyzers in C#, it will suppress certain rules for generated files. And I believe that the .g is one of the things that it uses to look for to determine if a file is generated.
And GitHub seems to ignore them in a PR.
GitHub ignores them in a PR because we instructed.
Oh, nice. Okay, so that's a feature. That's nice.
So if you look here in the template project, you'll see this Git attributes file where we tell GitHub that these are generated files.
Cool. So it's just a nice way so that you can know these things and you don't end up kind of tripping over yourself and having to review files that really don't matter. So I think the lights just went off in the room. Meg needs to wave her off.
We're all too still.
Okay, so anything else on the CodeGen stuff, Andrew? Because we end up building files out and then we actually check to see if the files have changed, right?
Yeah, so just as a matter of providing a nice amount of feedback to you as the person running the code generator, we check that the file on disk is the same as what we just produced as the output. And then we just don't print a message that it changed, and we don't write the file, so the modified date timestamp doesn't change if that matters. Your project, which it certainly can, in cases of caching build inputs, if your modified date changes and C# file is going to recompile that file, whereas if none of those dates change, then the C# compiler and .NET build tooling is going to see that and say, hey, that didn't change, so I don't need to recompile. So just a little bit of just stuff sprinkled there and there, here and there to make the experience a little better.
Nice. Great. I think that does a good job covering. Meg, did you have any other questions?
No, I think that's it. I think it's covered.
Hopefully that's helpful, like getting to look a little bit about how Coalesce kind of works behind the scenes, how some of the CodeGen works, how some of the Vite server gets spun up. Because really there's a lot going on here. And I think if somebody were to go in and try to build this by hand, there's a lot happening. So I think Coalesce really brings a lot to the table when it comes to just getting that project started and really being able to focus instead of, hey, how can I get all my tooling set up, which sometimes can literally take days and weeks. How can I just get started quick and really start building out value for whatever thing I'm doing, building a data model, building a front end, building a business logic. Getting that right away. So, Andrew, anything else you wanted to add, kind of in this vein, things that we missed, questions that we should have asked that we didn't?
No, I don't think so. Yeah, get out there and lead the docs, building more as we speak.
Yeah, awesome. Yeah, we've been working on that just real recently and trying to get those built out. And really, we're doing these just to kind of give the folks that find that really kind of the 10,000 foot view level of just kind of getting in and looking at things pretty helpful through these videos. So anyway, hey, thanks for joining us. Andrew, thanks again for coming on and sharing a little bit of a deep dive here inside Coalesce. And until next time, keep on building some awesome Coalesce apps.